So thanks everyone for coming to this session. I hope you've had a good couple of days at the conference. What did you guys think about the keynote? Excited, right? Are you excited about what we have coming up in visual analytics, sharing, collaboration, mobile, and what we're going to talk about today is represents an intersection of all of that, right? But before we begin, I just want to point you all to this mobile app. We work a lot on making these sessions useful for our customers. So regardless of whether you absolutely love it or not, we still want to hear from you. So if you don't mind, why don't you all take a moment and just see that you have that app downloaded. And I'll repeat this towards the end. Crucial that we get your feedback, and if you're able to, provide some description as well as to what is it that you absolutely love, what is it that we can improve on. So with that, let me just introduce ourselves. My name's Vaidi. I lead our big data product partnerships at Tableau. And what that means is essentially working with customers, understand how they're using big data from structured, unstructured data in Hadoop, cloud, and I spent many years before I came here as a customer of Tableau. So I was at GE's oil and gas business. And this is actually my 5th conference and just my 2nd as an employee. I attended 3 as a GE customer. And with here I have, I'm going to break into a little German, mein Freund from Mönchengladbach, Germany, Marius Kaiser. Marius, you want to introduce yourself?
Yeah, sure. Yeah, I'm super excited to be here. I'm a product consultant from the London office in Tableau. I came all the way here to Austin to discuss with you guys, I think, a really exciting topic, Internet of Things, IoT, and how we can make sense from sensor data. So, Vaidi, over to you. Just
Absolutely.
Give us an intro, what we're expecting. What you can
so, by the way, Marius, he's a Londoner, but he grew up in Germany, and he's still hungover from Oktoberfest. So if he acts a little funny, you can cut him some slack, okay? So just a quick overview of the agenda. The Internet of Things is a huge buzzword. Everyone knows about it, but we still want to spend a little bit of time just setting the stage and kind of track how we got here, okay? Then we're going to get into, if you don't mind, we just have phones off, but that's okay. Then we're going to get into some of the challenges around performing IoT analytics, right? The platforms have absolutely taken off, but there's not been a ton of innovation around helping people see and understand that data and helping people of all skill sets, right? It's great for engineers, it's great for those working on power plants or actually building those technologies, but how can business users or the everyman make use of that data to drive insights? That's something we'll touch on. Then we'll jump into some actual demonstrations. We'll pick apart some use cases, both industrial as well as related to consumer applications. And there's 4 distinct use cases we're going to demonstrate. So that's what we call what customers are doing with sensor data. And then towards the end, we'll just recap some best practices. This is where I'd like to open the discussion to everyone in this room. I'd love to hear from you around what you're doing and what we at Tableau could do better and hopefully incorporate into our roadmap. I'd love to know that. So we'll spend some time on Q&A as well. So without further ado, I'm just going to send this back to Marius, who's going to tell you how we got here.
If you give me the clicker, perfect. Awesome, guys. So how we got here, that's a great question, because right now we are experiencing another chapter of the process of industrial revolution. So similar to what steam engines and machines did to our lives and how we work and interact with each other 200 years ago, and similar how the internet changed the whole business, right? Just creating new business models by connecting us, giving us computer processing power, data networks, and pretty much free access to information and knowledge. So business giants like Facebook and Twitter were born in this age just a couple of years ago, pretty much. And now we're seeing a new age, an age of data and sensors, because everything, we can blend those two worlds together, the digital world and the physical world. And that's what we're experiencing right now. Everything is interconnected and sends data to the cloud, and where we then are able to make sense out of it. So that's where we stand right now. And let's have a look how technology enables this trend. So on the one side, sure, we have our sensors and the data storage, which is getting cheaper and cheaper. So this is pushed by the trend of cloud computing, right? Storage doesn't cost anything at the moment, but we have massive amounts of processing power available because we can scale that easily. It's super accessible, enabling big data technologies, enabling us to use these volumes of data and build analytics on top of that. And then we shouldn't forget that networking, so the new introduction of IP version 6 is now enabling us to bring all those different devices, phones, fridges, everything onto the internet and let them talk and interact with each other. And that's exactly the fact which is disrupting a lot of industries and technologies at that point. So if you look at the automotive sector, cars are packed with sensors. If we look just at Tesla, the most modern car manufacturer, I would say, it even enables us to, that the car drives us from A to B autonomously, right? Similar in the aviation sector, where all the viable and important instruments are connected to the network and sending their data back to the manufacturers where they can use the data and get insights out of it. Industry and autonomous factories were one of the first use cases of IoT. Then we have some newer businesses around retail and marketing. We're going to go that into more detail in a second. And healthcare as well, right? So just by the show of hands, who's using a fitness tracker or a smartwatch? So I definitely do. And this is a sensor, and these sensors are getting more powerful, and we're able to tap into the data, and that will disrupt the healthcare sector then at the end as well, right? If we want to have a look at some outlook that McKinsey gives us for 2020, we will have over 25 million apps in the IoT space, and the whole industry will be worth $4 trillion, generating 50 trillion gigabytes of data. That's a massive amount of data, which is a challenge, right? It's a challenge to analyze that and make sense of that. So I just want to get a quick feel how you guys see IoT and sensor data. So who has sensor data right now in their organization or use it privately? Just by the show of hands. Wow, that's a lot. That's a lot of people. And who's actually building analytics on top of that? Who's using that data as well? Okay, a bit less, a bit fewer, but it's a very advanced audience already. I like that, cool. But what you can see here as well, that IoT analytics didn't quite start off yet, right? We have the huge hype and the trend, but analytics are still lagging behind. Vaidi, can you tell us a bit more about that? Oh.
So the next 5 minutes, I just want to kind of touch on what plagues IoT analytics today, right? And this is not so much on the lack of technology. There's a lot of technology already out there, but it has more to do with them not, or our inability to bring them together in a useful way, right? So there's many companies see it in different ways. Several organizations have researched this question. Here's Gartner's view on this. They call it the hype cycle. How many of you have seen this chart, follow this chart? They come out with this every day. It's a great representation of how technology is mature. And the way you read this chart is, every time you have a new technology breakthrough, right? This is where the technology takes birth, right? And soon you see that there's a lot of, there's proofs of concept, there's massive media publicity, and there's a lot of success stories, but those success stories are also combined with scores of failures. So before long, you reach this peak of inflated expectations, and that's where IoT platforms are today, right? And once you're at the peak of inflated expectations, what happens is, customers start actually wanting to see more value. And when reality doesn't meet those inflated expectations, soon you enter this trough of disillusionment, and it takes a lot of time before all that technology crystallizes and drives this plateau of productivity. So where IoT platforms today are very much close to that peak. Okay? Now IoT, the specific challenge that plagues IoT analytics, I call it the last mile problem. So let's separate this problem into two phases, right? There's the innovation that has happened around devices and sensors, around capturing data from remote platforms. These could be your consumer applications, refrigerators, home automation systems. It could be the blades of a jet engine or an oil rig 200 feet below the ocean, right? But a lot of the solutions that have been built around these remote data are all one-size-fits-all solutions. And what do I mean by that? By one-size-fits-all, I mean they are only designed to answer a certain set of questions. And what that means is that there are several users who are left out, right? And what I really mean by that is you have only built this to satisfy one or two or three use cases. But there's 1,500 use cases that could potentially have been supported with all this data, but that never happened, right? And this creates a bridge, and I call that bridge the last mile gap. So there's three key hurdles we need to overcome to address that gap. Let's step through these. The first is you need platforms and you need to design experiences that are fast and flexible. Well, fast goes without saying. CEOs across the world are making investments, and in order for those investments to drive value, they need technology to be adopted fast. So these are the results of a survey conducted by the Boston Consulting Group, and it was loud and clear that speed was the number one criteria that supported the evaluation of big data investments. And in a world where perfect data is an oxymoron, there's no perfect data, right? There's always some cracks in the data you have. The way you achieve speed is by iteration, agility, and experimentation, right? And the way iteration happens in an analytic cycle is sometimes you start with a question, you answer that question, you put it through a feedback loop, you validate it, which lets you ask the next question. Sometimes when you don't have a question, you just get some data and find questions that are worthy of asking and answering, right? So iteration is absolutely crucial to enable speed in an organization. The second is that you need platforms and design experiences that allow for deeper exploration. And just to make this real, I want to harken back to Steve Jobs' iPhone keynote from 10 years back. And this was 2005, and there's something he said that applies as much to the world of phones as it does to the world of analytics. And I'm actually going to quote him here, and this is exactly what he said. He said, and the context here was he was trying to contrast the new revolutionary giant interface with the existing technology of that time that put buttons on phones, all right? And he said that every app needs its own screen, its own UI. Buttons don't work because buttons and controls cannot change. They can't change for each application, and they can't change down the road if you think of another great idea you want to add to this product, right? Now, I just want to keep that in mind and think of how that applies to the world of data. In the world of analytics, every question needs its own chart. It needs its own way of representing that information, right? And what you cannot do is force fit your analytics into these one-size-fits-all platforms. And I call them dead-end dashboards. Dead-end dashboards are the so-called purpose-built custom platforms that answer 5 questions, but what if you want to go beyond that? To give you an example, I mean, there's so many of these. I'm not going to mention brands, but you could have a platform that tracks the activity or the failure conditions of a broken jet engine, right? And it might tell you what conditions lead to failures. Who's in manufacturing here? Well, that's interesting. Gartner says the most common IoT use case is in manufacturing and optimization, but that's interesting. So you could have an app that tells you which conditions lead to failures, but what if you want to ask the next question? What if you want to know where did those failures happen? What parts failed the most? In which factories? Which supplier supplied those parts, right? You need a way to bring all those data points together, which is why these dead-end dashboards or these custom purpose-built solutions do not work. And how do you make them work? Or how do you design experiences to enable that? Well, you have interactivity. Interactivity is all about having conversations with your data. When you give your users an interactive dashboard as opposed to a static view, he is able to develop his own threads. He's able to ask and answer his own questions. And as someone who builds the dashboard, I don't have to second guess what he is going to ask. I can give him everything in an interactive way and let him explore his data how he wants it. That is ultimate self-empowerment. Okay? And the last thing is you got to foster sharing and collaboration. And this extends beyond technology. Of course, in Tableau, we're absolutely proud of how Server is built to share, distribute, and collaborate insight. But why I say it extends beyond software, it's also about how you run your organization, right? How many of you here have analytic centers of excellence? Or where you have a hub and spoke model, where you have people who build dashboards and people who are analytics experts are tied via a matrix to a business owner, right? That's how it should be done, right? So here's an example of an actual customer example. This is from my days at GE, and I absolutely love this, and the team I work with is still a Tableau customer. And this was an IoT-enabled manufacturing plant that is supplying defect data to Tableau, right? And what's going on here is that with Tableau Server, an observation that you made is actually becoming an insight because you're able to share and collaborate with that information, right? So here they've spotted a defect. They have attempted to understand why, where, and on which job that defect occurred, as opposed to learning that after the fact and pouring, tons of money into removals and fixes. Right? It helps them be proactive and do the preventive work beforehand, and use that to preempt future occurrences of that problem. And then there's a fourth hurdle, which is, of course, you can't ask too much of the IoT. Right? If you want to go out on a date, just do it. Don't let your device tell you to do that. Okay? So just to recap those hurdles, and we'll let these manifest themselves in the demonstrations we're going to show you. Fast and flexible, enable exploration, go away from dead-end dashboards, enable interactivity, and finally, always think about how you're going to share and collaborate, or share and distribute that insight so people can collaborate and develop their own insights and threads. So with that, I'm going to send this back to Mars, and we're going to go into some real use cases.
Cool. Thanks, Vaidi. So we at Tableau, we want you, our customers, to be successful, right? So we love data, and we want you to be successful with your IoT projects. I want you now, after this talk, to be more confident about IoT analytics and that you can actually easily tap into this space as well. You can use this hype and trend as well. So let's think and let's see how Tableau can help you guys to tackle these challenges we just heard from Vaidi. So number one was, we need to be fast and flexible, right? And the most important part, the foundation, is the data. We need to be able to connect to the data. And we give you all the flexibility you need there. So you can have a database on-premise in the cloud with structured, unstructured data, or even a big data environment in the cloud. With 10.1, we now introduced the JSON connector, and this is just that's just the beginning, right? We're adding more connectors with every release, and to give you all the flexibility that you need. And on top, we have the strength we all love. That's why we're all here at Tableau conference, right? On top of that are the strength of Tableau. So bringing that data together and using that data layer to find insights. With the analytical skills, we can generate insights very fast, and it's still unchallenged in the market at the moment. And then we need to share and collaborate on our insights. We need to share our visualizations, our dashboards, right? So there again, we can share this on Tableau server or on Tableau online in the cloud, or we can bring it together. We can deploy Tableau server on AWS, so it's hosted in the cloud. So we give you all the flexibility you need there. So let's jump into some examples where we see some real IoT data used and generating insights. So I'm a product consultant, and I work every day with customers like you who want to get the most out of Tableau, and I help them to be more successful and build their use cases and proof of concepts, right? So I want to talk to you, or we want to show you today four examples. 3 are industry examples, but the first one is a personal example where I wanted to see, London is infamous for the bad air, for the smog. Is it really that bad? Does it influence my life at my place? So that's what I want to find out, and we're going to use data blending to bring the data together there. So each of these applications have a unique use of sensor data, what we wanted to show you, and what you can use in your projects, and is adaptable in your organizations as well. The next one is marketing analytics. We wanted to visualize where people are moving around in a mall using beacon technology. And then we're going to use data exploration on top of airplane engine sensor data to find the low-performing engines which are dangerous for our business, and to optimize maintenance for these. And then finally, we're going to show a whole IoT application on top of power plant sensor data to be able to monitor and to act fast when we have critical states. Okay, so if you were wondering, by the way, who this little guy is, so so this is R2CO2. This is my body, my air quality sensor, right? I got him to help me to understand how the air quality is at my place, or in the office, or here right now. So he can track right now the air quality in this very room, right? So he checks the temperature, the CO2 obviously, because that's where he got his name from, and the small little particulates in the air. They're so tiny we can't see or smell them, but they're really dangerous for our lungs at the end. So we really want to see, are we exposed to this during our day or over a long time span. So how I built this whole setup now. So we got R2CO2 here in this room. To be honest, right now he's not live because I couldn't connect it to the Wi-Fi, but let's imagine that's the case. So he is sending the data live into the cloud. Let's call it the Cloud Galaxy, and a really cool web service, if this then that, can trigger a new line in a Google Sheet. So every time this air quality sensor has a finding, or like every 5 minutes has a reading, this will be sent and triggered to the Google Sheets. And as you probably know, we can connect live to Google Sheets with Tableau and tap into this data. So I would say let's jump right in and have a look.
By the way, before that, just quick, so this, just to demonstrate a proof of concept, we've used Google Sheets, but this could be Redshift. This could be Cloudera Hadoop. It could be any of your own data warehouses. And this if then that, this is again for demonstration, but you could write your own web service to capture that data, right? So if
oops. Yeah, I'm a first-time Mac user. So.
What do you want?
Okay,
yeah,
got it.
Good.
So we are now connected live to the Google Sheets. So let's have a look at the data first. Let's edit the data source. We're connected to Google Sheets right now. It's live, and we can see here I unioned some of the tables together. So we can use union in Google Sheets already. We could use a wildcard here as well to make it more automatic. Because I have a couple of sheets already. I tracked some data in London where I'm working right now, but as well some data points here in Austin. So I brought these all together, and let's have a look at the data. So to get a sense of the data, let's have a look at the number of records. So we've got around 5,000 records here, which is then when the sensor is connected to the internet, will update every 5 minutes, and we get a new row in our data set. So let's explore the data a little bit. We can compare this by the location. So we can see, for example, we've got Austin here in orange, and then the most data was tracked at home at my place in London. That makes totally sense. And at the beginning, he was in London because I want to track the air quality there as well. I'm in the office, so that's the Tableau office in London. So these are the number of records, but that's not too interesting, right? So let's check the actual sensor values that we're able to track. So let's drag these in. So we got the temperature in the bottom here, and we can see it's on average very, very similar. At my place, it's a bit colder, but that's just because of the aircon. But what we can see, what's very interesting, the particulates, what I was talking about, and the CO2 is way higher in my place than here, for example, or in the office in London. That's because here, the air conditioning is changing the air constantly, and we always have really good air quality. So that's a great news for us. And that's why we have such a great time here at TC, probably. And but what that means as well, like the air quality at my place is not that great. So apparently I'm living under a bridge in London. Maybe that's the case. The rent prices are really, really high there. But I don't want to get into that detail now. So what we want to see now as well is the trend, obviously, right? That's how we investigate sensor data. In most of the cases, we look at the trend over time. So we can quickly change this to an hourly trend. And we can see nicely now by the color coding. First, he was tracking the data in the London office, then at my place, and then here in Austin, here where I was traveling, so we don't have any data there, and then Austin. But the location here is not that important. So let's remove this from the chart and make this a bit more colorful because I like colors. So we have the temperature here at the bottom. It's not too exciting, right? It's temperature. It's always around 23 degrees or around 70 degrees Fahrenheit when I'm correct here. So that's not too interesting. So let's remove this. CO2 is a bit more interesting. So we have a massive peak here at the beginning, like in the first week when I started to use the sensor. And yeah, to be honest, the story here is I was quite lazy. I just put a pizza in the oven to get some quick food after work, and I fell asleep. I was too tired. The pizza totally burned and smoked through my whole apartment. And this is now tracked in the with the data. So that's pretty cool. So I only did this because so I can have a nice story here, right? So that's the only case. But I really want to investigate more into the particulates, but because that's really dangerous for us, actually. And we can see a nice trend over time here. This value seems a little bit too high because it's a huge outlier, and it was way lower at the beginning and drops right away. So I think could be a wrong reading. So that happens with sensor data. It's not perfect, but we can go ahead and just exclude this. So to get more, so that looks way better now. And so this is over the case of an hour now. We can aggregate this over per day, because I want to know if I am hitting the limit. So the US limit for these particulates are 35 per day. So I'm not hitting that limit, so I'm still good in that case. But yeah, we're talking about bringing data together as well, right? So let's do this. So I want to compare the data now with actual air quality sensor data from Austin and from London, which were from official institutes. I found that data online and brought this into and copied this into an Excel spreadsheet. So we've got Austin over here, and here again we can make a quick union, get the data together, and now we're able to analyze this and bring it together with my actual data. So let's have a look how this looks over time as well. Let's check it out per hour. We can do that as well. And we need to split it up by city. So to get a better sense, actually, let's use day. And we can see Austin is actually way better than London. It's really true. The air quality is not great in London. But we wanted to compare this with my data, right? So let's bring this in. We just switch the data source, go over to my readings, get the PM value over here. I need to change this to a quick average. And now we can compare this. Let's have a look at the bar chart again. And we can create, let's overlay these two charts so we can compare this in a more, in an easier way, right? Okay, so the air quality at my place, which you can see in the gray bars, is actually correlating with the values in London. So that makes sense, right? And then we can see Austin is better than the values at my place and in London. So if I want to continue living in London, I should really be aware of how the air quality is around me, and I shouldn't hit this limit too often, right? So we're here at 45, and let's bring in a constant line to visualize the limit here. So this would be the limit, and in London it's actually over this limit. So over a longer time frame, this wouldn't be healthy at the end. So so I want to monitor this data now, right? So what would be the best way to do this? Obviously, a Tableau dashboard. So I hope okay, perfect. So I built a dashboard on top of this data, and I can track this now every day. This is connected live to the Google Sheets and is updated every 5 minutes. So that's awesome. I can subscribe to this dashboard and check it once in a while, but I'm not always on my desk or my laptop, right? So I want to view this on my phone as well. So let's have a look how that would.
Yep, I'm just trying to bring this up on my phone.
I just hope Air Server doesn't let.
Yeah.
Otherwise, maybe try again.
So we have this app that allows us to project.
Oh, we got it here.
Oh, there
we
you
got
go.
it here.
Okay. All right. Perfect.
Cool. So we got this now. We got the same dashboard now on the app, right? So I got this all on my phone. We see that here, and now I can track every hour, every day how the air quality is. This is fully customized and optimized for the phone now. So the most important metrics I want to track, I can see the limit here as well. I can check how the particulates trend is, the temperature, or the CO2, for example. Just on my phone, and it's the same. It's the same dashboard, just optimized on the phone. So that's awesome.
And those of you who've used Device Designer, these two renderings didn't have to be created twice. It's one dashboard, and just with one click, you can control how it's visible on different form factors. So the same dashboard, you can tell Tableau, hey, display it on an iPad, and I don't need 4 worksheets, I probably need just 2, right? So you can control how it's seen when you design it.
Yep. Thanks for that. That's exactly the case, and how, as Vaidi pictured out already. So that was a small little project of mine, a small experiment, to really see, is it really that easy to connect sensors together, to use their data, build analytics on top. But as you can see here, you can just exchange Google Sheets with Google BigQuery, any cloud database really, and you can exchange if this then that with the IoT platform in the cloud, AWS, and within a day you can plug your sensors in and you're ready, you're good to go. And you can analyze and tap into the data with Tableau, right? So let's have a look at the use case we did for a team of marketing analysts. And they had a project where they use beacon technology. Beacon are like, you can imagine them like lighthouses. They send a Wi-Fi signal and they can track which devices are in the area. So we can use that data to approximate where customers are walking around in a mall or in a shop, for example, and then giving personalized marketing to them as well.
There are beacons at the conference venue as well, by the way. So every time you switch on an app, that beacon will know where people are. But it's all de-identified, so.
So we're connected to this cloud database now, which has the data, and we can create a simple analysis. For example, we count all the different devices that are in the area over the course of the day. We have over 6,000 here. We can use the timestamp here to create a quick trend over the course of every minute, for example. And we can see two peaks here over 5 p.m. Actually, let's use the area chart that looks so it's a bit easier to see. So we have a peak over here. Let's make this full size, actually. Yeah. So we've got a peak over here, like after office hours, usually we have a peak here, and then around midday for lunchtime probably as well. And then here at that time, around after 7 p.m., we're closing the mall, so only security people are around, so that totally makes sense. And then we can analyze as well where people were moving around. So let's use the X and Y coordinates that we were generating and track this on our mall layout, right? So to get a context where the people actually were moving around, we can look at this on a device level, and we can see now in which area the people were moving around, right? So that's pretty nice, but Tableau gives us more sophisticated ways to visualize this kind of data. So I'm a football fan, or soccer, and they usually, or probably American football as well, they analyze location data with heat maps. So I like heat maps, and I want to create a similar heat map with Tableau. And let's have a look how this can be visualized. So this is not it's not a default visualization. I'm not going into detail how to create this. There's another session I will relate to later, but that will tell you exactly how to do this. There's a whole session about this. So we're creating hex bins in order to get a heat map to really see where the customers moving around in the mall. So we got each of the stores here, right? And we can really see in this area, most of the people were moving around, and these are the most popular stores at the end. And the power comes to really when we bring those information together. We can bring together when people are coming in and where they're moving to track campaigns or the impact of the weather or special kinds of events or marketing campaigns. So we can work together with our mall customers, with our partners who actually have shops in our mall, retail customers. So we can track who are the popular stores, when are the customers going into their stores, and this is very valuable information for our partners there. So this is just a showcase, so these are not the real stores, just to give you an idea how they could work. And then we can create kind of market basket analysis, which customers are going to maybe to the electronics store, where do they, which other stores do they like to go, so we can track their preferences. We can see their preferences. So we can see, for example, it was quite interesting that when we look at the coffee shop, they really like to combine coffee and pizza. So this enables like cross-marketing as well, right? And we can see when they usually go to that shop. So at the end, what we can build out of this information is a whole customer profile. We see their interests, their shopper preferences, when they come in, where they're going, and we can give them personalized marketing. So in London, every other store has a beacon at the entrance, and I always get deals on German beer. I have no idea how that comes, but I get the best deals in London on German beer. I have no idea how they came up with that. So that's just a simple use case when it comes to marketing, right? To visualize marketing data. And now I would pass over to Vaidi again. That's
Awesome.
Let's start
So for
your
this section of the
presentation.
demo, we're actually going to go do some impersonations, and I'll try my best. And I'm going to assume the persona of an aircraft engineer who wants to be an aviator, all right? And I'm going to go in and try to monitor engine health using Tableau. So again, the use case is something all of you may be familiar with. Those, how many in aviation? And what aviators do you work for? I mean, airlines, jet engine manufacturers? Honeywell, okay, perfect. So blades of an aircraft, you know, or the wings or the blades of a jet engine, all of these are being embedded with sensors, and they're sending data back for engineers to analyze, right? So here is a use case where I am going to capture all this data into an on-premise database, and I want to answer some very simple questions. I want to look at engine temperatures to find which ones, or to separate the low-performing ones from the top-performing ones, and the analysis that I'm going to do is predicated on the fact that engines usually operate in a temperature channel, right? Too hot is bad, too cold is bad as well. So we're going to explore the too cold scenarios here. And of course, that tells us which should be put on a service schedule, right? So very simple use case, and let's attack this with Tableau. Let's see, what am I doing wrong? Yeah. How do I minimize this? Hold on. How did you alt-tab? Again, this is a new Mac user as well.
I'll just end show.
You just end show, okay. You do it. Bring up Tableau. You know, PowerPoint is harder than Tableau. Perfect. All right, so I'm just going to just cross out everything. So here's the data set I have. And before I get into the, I'll just want to show you what's in the data, right? So every row is some information about an engine, okay? So you see things such as what the airplane ID was, what was the city in which the data was captured, what phase the plane was in. Was it cruising? Was it taking off? Was it climbing? And you see there's a lot of nulls because, you know, not every engine transmits data all the time. Sometimes there are nulls, and you have to work with those things, right? So the first thing I'm going to do is I'm going to just take a look at how many engine IDs there are. So there's about 55 engines. And I want to look at the average temperature over the last 30 days. And for those of you who don't know what I did a little trick. This is something you can do as well. So if you want to drag your measure into Tableau without necessarily performing a second step of, you know, making it continuous or discrete, you can actually do a right-click drag. So that's what I did here. So average 30 days. And for those of you who want to know how I came up with this, it's a little LOD expression, and I can show you after the session what I'm trying to do here. Okay. So think of this as the average critical temperature of the last 30 days. And I'm going to bring this into the view. And yeah, let's look at the average. Okay, perfect. So that's kind of nice, except I don't necessarily want to look at all these engines that do not have any data. So I'm just going to filter those out. And I want to color them by the minimum critical temperature. Well, that's kind of nice. But wouldn't it be cool if I could compare that average 30-day temperature relative to a threshold, right? So I'm going to go into the analytics pane. A couple of years back, you actually had to do a right click and do 5 or 6 clicks before you added these reference lines. Now it's just a drag and drop action, right? And I'm going to make that 38. So now everything below 38 is something that I want to further investigate. I'm not sure yet, but I want to keep them for further analysis. How do I do that? Well, I'm just going to go ahead and create or put them into a little set. Right, so let's create a little set called low perform body. Right? But what's wrong with what, I mean, it's not wrong, but it's not, what's not optimal with what I've done so far? I have computed the average temperatures over the last 30 days, right? What I really want now is I want a daily trend. Because every time you perform a service operation, temperature changes, right? And I need to look at what happened every day to see if the engine was responding to what I did, okay? So that's the next thing I'm going to do. I'm going to look at the minimum critical temperature here over time. And let's make this continuous. Let's make this month or even week. All right. Well, that's cool, except you see there's a lot of empty space between 0 and 35, right? So a chart analogous to this, just to help you put this into context, is let's say if I were to visualize the best times set in a 100 meters Olympic race. There's going to be a lot of empty space between 0 and 8. So if you really wanted to see the impact Usain Bolt has had, here's what you would like to do. You would like to go ahead, edit the axis, and omit 0. Right? Now you see what's going on, right? Everything between 0 and 35 is useless. Temperatures don't get that low, right? It's a small range that I'm interested in. But there's still a lot of fluctuations. I want to smooth this out a little bit, right? So I can go ahead and just create a quick table calculation and just make this a moving average. And I want to compute the moving average over the last 7 days. All right? Well, that's cool. But this is still an aggregate over the entire data set. That's not what I want. I want to disaggregate this by engine ID. I want this curve for each engine ID. How do I do that? I can just bring engine ID into the level of detail and voila. Right? We're not there. We're getting there, right? This is all about exploration, right? Each answer is leading to the next question. I'm not thinking of these questions in advance, although I did, but you see what I'm saying. So there's every engine I have plotted out over the last year. But remember, I created a little set in that previous view. Well, I can use that in here and see how the low-performing ones stand out relative to the others. And I can look at it different ways. So here I have looked at color. Maybe I want to bring that into filter. Maybe I want to just look at the low-performing ones, right? Maybe I want to keep it like this and bring the engine ID into color. I could do that too. And let's change the color palette. Let's say not this. Let's make it automatic. Assign the palette. Yep. Right? So now I can actually step through some of these and I can actually bring the low performers back in here. And I can individually inspect some of these engines. Now, if you look at them, you see a couple of things. First, and what engine is this? This is EE1279X, right? Now, as someone who maintains these aircraft engines, I know that this engine had a service event on the 13th of April, okay? So that's when there were some issues. We fixed them and the temperature rose, but immediately in a couple of months, the temperature started falling back. That is, to me, that is not optimal. It should plateau after that. So I am going to go ahead and keep this for further analysis. Here's another one that doesn't look right. So how about I select both of these, and I can say keep only. Oops. Or maybe I do it this way, yeah. This and E126. And those are the ones I could then publish to Tableau server, or I could go ahead and also potentially create a dashboard that brings all these views together, maybe even adds the operator. So maybe I want to do that. So I want to look at engine ID, who's operating it, and the minimum critical temperature. Bring it all into one view. And what I'd like is the operator to be in color. Well, that's better. And I can create a really quick dashboard object. Apply some filters. And now, whoever I'm sharing this with can explore it as he wants. All right? So that's, again, a very simple use case of how you can take sensor data emanating from a jet engine and use it to drive your performance schedule. All right? So the next use case I'm going to go over is another industrial application. How much time do we have? Okay, we have 10 minutes. And this is power plant analytics. So time for my next persona. I'm going to be an engineer now, right? Very similar use case, different site, different operation. Instead of putting sensors on the blades of a jet engine, I'm putting it on a gas turbine or a steam turbine or whatever is, helping me power my customers. And I'm capturing that data into a cloud database, okay? And as an on-site engineer, I want to visualize my install base and see which ones are in a critical condition, and I want to use that information to alert whoever needs to be alerted. Very simple use case, all right? Now, imagine I am on site, and I don't have access to a computer. All I have is a mobile device. Can I quickly get a sense of what's going on, where my turbines are, and which ones should drive a scheduling call or whatever, right? So let's try to do that. So I'm going to project my Tableau iPad app now. How many of you use the Tableau iPad app, by the way? Okay. Now, for now, we're going to connect online, but for those of you who attended the keynote, very soon we'll have the ability to interact with your mobile dashboards even when you're offline. So that's something we're very excited about, right? So let me just go ahead and project this. Excellent. So here's the app. Again, gives you a very simple view of my install base. It shows me how many critical events I have. I can select a certain turbine that is of interest. And let's say I want to go ahead and monitor all the KPIs for that turbine across time, right? I can do that. I can see that the water pressure capacity and the water inflow capacity are within range. I can see over here that there's some, what's going on with the resolution? That's something we could have done better with. But again, all that tree map at the bottom left-hand corner is telling you is which events are critical. So I might want to just deep dive and see what KPI is driving that criticality. In this case, it's water temperature. And I also get an event overview. So I can look at every event, whether it was a warning, whether it was critical, whether it was normal over the last 24 hours, broken out by time. And I can go ahead and also select some of these for further examination. So maybe I want to just inspect the details here. Right? And I immediately get a detailed view. So now I have not just the overall aggregated data that tells me events over the last 24 hours, I can also see what actions have been taken on those, and if I find that something suspicious, I can just click on that particular event, and it will fire an email to whoever needs to be alerted, right? So making that app would be minutes. I think where a lot of work will go in is to match the data and make sure it's the right format and that kind of thing. But again, all we're trying to do is we are creating an experience that is available on all places, right? Regardless of what, you could be online, offline. Your data could be in the cloud, on premise. You want to consume your data on desktop, Mac, mobile. It's available for you. Okay. So I'm going to go ahead and exit this. And yeah, let's just recap some of the things we've learned today. All right. So again, and I can go back to just being a Tableau product manager. So the idea today was to give you confidence and inspire you and tell you that IoT data is available to be analyzed. It's probably not always in the right formats, but we have a whole slew of partner technologies that we work with, and you can find them in the expo hall. They help with data prep, Trifacta and Paxata, leading technologies that work, that help prep data in Hadoop and that help prep unstructured data as well. We work with the biggest storage and processing vendors, so all the major Hadoop distributions, Amazon, Google, all the major cloud platforms. And there's also several query acceleration technologies and fast analytics databases that have influenced how they build their product to integrate with Tableau. So let me know if you have any questions around how we can help you think about IoT data better. And if you need any introductions to these technologies or need some help with specific use cases, we're going to stick around. But until then, I want to thank you all for coming. And again, I had a little reminder before. So please rate us. We love to hear from you. Feedback is what sustains this conference. So thank you so much, and have a great rest of the day and the rest of the conference too. Thank you.
Thanks, Timothy.
Oh, and before we leave, this was just, I think, the first IoT session of this conference. There's a couple more that are happening that you absolutely want to attend. Highly, highly recommended. You connected what to the internet? So this is, so while ours was a little, I would say 15 minutes of overview and some use cases, here was, this is an entire hour worth of just a demo, okay? So definitely attend that. And of course, I forgot to mention, I think we have some time for Q&A as well, so please, fire away. Yes?